Okay, so the problem that I got for my oral assessment was for all integers a, b, c, and d. If a divides c, then b divides d, then a times b divides c times d. So to start out our proof, I did an introduction basically to the problem that says a, b, c, and d are integers. We suppose that a divides c and b divides d. We wish to show that a times b divides c times d. So we know that a divides c, which we can then write as c is equal to a times an integer, and right now we can just call that integer m. And we also know that b divides d, which we can then rewrite as d is equal to b times an integer, and we'll call that integer n. We wish to show that a times b divides c times d. So we can then rewrite that as c times d is equal to a times b times some integer. We don't know what that integer is. That is what we are basically solving for. But since we know c and we know d, we can then plug these back in for our what we wish to show. So we have a times n times b times n is equal to a times b times some integer. We can then factor out an a and a b, which then gives us m times n, and n times n being an integer. We have then solved the right side of this equation, then figuring out what our some integer is, proving that a times b divides c times d. So, therefore, a times b divides c times d by the definition of divisibility c times d is equal to a times b times m times n, where m times n is an integer. And that is my oral assessment.